All right, this video is about identifying functions. Previous to this, you should have watched a video or learned in class about what a relation is. All right, a relation being an expression or a graph, or anytime you have a situation that relates an input to an output, as we saw in tables as well. Well, a function is to a relation as a square is to a rectangle. Pause the video, take a moment to think about what that means. Well, if you thought about it, maybe you came up with some ways to decipher this analogy, and you thought about the fact that a square is a special type of rectangle. All squares are rectangles, but not all rectangles are squares. All right, well, that's true of functions as well. All functions are relations, but not all relations are functions. That's because functions are a special type of relation. All right, so functions are always relations, but relations are not always functions. Our goal in the rest of this video is to show you how to identify when a relation is a function and when it's not. And if you were in class, we had a nice little demonstration here where we had ourselves a soda machine, and we had students come up and they selected the soda that they wanted just by pressing the button. Now, when they pressed that button, they got a certain soda out in return. All right? And what that soda got out the first time was what they expected. All right, so in this case here, if I were to come up here and I were to select something like Coke, well, then I got a Coke. All right, if I were to select Sprite, well, then I got a Sprite. Fanta, then I got a Fanta. And we noticed the machine was functioning, all right, because we got what we expected. When we pressed an input, we got the output expected. Next up, we had people come up and they selected Coke and I gave them Fanta. They selected Coke Zero, I gave them Sprite. They selected Sprite, I gave them Dasani. They selected Fanta, I gave them Sprite. Someone else selected Fanta again, I gave them Coke that time. They selected Fanta again, I gave them Powerade that time. They had no idea what to expect. When they pressed a button, they had no clue what was coming out. This machine was not functioning properly. All right? It's functioning when I know what to expect when I press an input because I'm always going to get the same output. So then we looked at a different scenario, which was unique. This time they came up, and when they pressed Coke, they got Sprite. And they came up, they pressed Coke Zero, got Coke Zero, Sprite, they got Sprite, Fanta, Fanta. Someone else came up and pressed Coke again, and they got Sprite. They pressed Coke again, they got Sprite. Coke again, they got Sprite. Was this machine still functioning? Yes, the machine is functioning. This button right here is mislabeled. But you know what you're going to get if you press Coke. If you press Coke, you're going to get Sprite. You can predict the output because the output is the same every single time I press that input. That's what makes it a function. Let's take a look here as we look at our functions. Now, in this case here, we've got ourselves a table with our button number. And we see if I press 1, I get sticks. All right? If I press 1 again, I got sticks again. It's functioning. Every time I press 1, I got sticks. I pressed 2, I got M&Ms, still functioning. I pressed 4, I got M&Ms. That's okay. 2 can get me M&Ms and 4 can get me M&Ms. But then I pressed 2 a second time and we ran into an issue. The first time I got M&Ms, the second time I got duds. That is not consistent. Every time I press an input, I should get the same output if it's a function. So we found that this is not a function, it is a relation only. And that's what we refer to it as. I mean, you could say not function, but most of the time the options will be, is it a function only? Is it a relation only? Is it both a function and a relation, or neither function or relation? Well, it's either a relation only or it's both a function and relation because all functions are relations. So let's look at it with numbers. When I have a table with numbers, I want to look at all the inputs. If an input repeats, then I want to check to see if the output was the same. If an input does not repeat, then we assume it's functioning. Take a look at B here. If I look at my inputs, 7, -2, 0, 4, 9, -3, 6, none of them repeat. So I have to say that this is both a function and relation, because all functions are relations. I'm going to abbreviate writing that from here on out, just so you're aware, but that's the options. It's either relation only or it's both a function and a relation. Look at C. In C, if you pause the video, try to examine it on your own. All right, coming back in now, hopefully you notice there are 2 inputs that are the same, 2 and 2. All right, first time 2 got me 9, second time 2 got me -8. That is not functioning, so this is a relation only. All right, that's for our tables. What if I give it to you as a set? A set And you can go look at our domain and range. It'll talk more about what set is. But set notation is basically giving us a set or group of values. All right, sets are marked by this funky bracket on the ends of either side of the set. Sets can be just numbers. In this case, the set is of points. It's giving me a set of ordered pairs. All right. Now that set of ordered pairs, I'm going to ask you, is it a function? It's hard to notice in that format. But what if I wrote it in a table format like we just looked? Notice this represents the same thing. Here I've got the point, -8, 11. That's right there. Here's 4, 3. All right, here's 11, -8. All right, in table format, I looked at my inputs to see if any of them repeated, and I saw -8 repeated itself. And I looked at its output, and did it give me the same output in each case? In this case, yes, it did. So the same thing here. Look at the x values. The x values represent our inputs. And I notice that I have 2 of the same x values, 2 inputs, -8, that are the same. And I also notice that I got the same output each time. So this is a function and relation. All right, let's take a look now at the next one. All right, look at your inputs. Try to figure out if this set right here is a function. All right, coming back, I see 4, -1, -2, -1, 7. -1 repeats itself. And I got a 6 and a 7. That is not a function. This is a relation only. All right, take a look at the next one. See if you can figure it out. All right, coming back in, I've got 2, 3, -5, -2, 0. None of my inputs repeat, so I must assume it is functioning, so it's both a function and a relation. That is identifying functions in a table or a set. Let's move on now to graphs. All right, in a graph, we are looking at finding our inputs. All right, our inputs are represented by vertical lines because the input of -2 would be this line right here on this graph because that's where x is -2. And any point we come across on the graph, like right here or right here, all right, it has an x value of -2. If I were to write that ordered pair, looks like it's maybe like 1.5 or something like that. All right, this one here, it has an input of -2, an x value of -2, and it looks like maybe -2.5. Okay, just giving an estimate. That looks like 7.6 though, but 2.5. All right, so as we look at this, the inputs are represented by vertical lines. Okay, so how can we tell if it's a function? Well, remember, any input should only have one output. That means any vertical line should only touch the graph once. If I draw that vertical line again, I see it touch the graph 1, 2 times. That means it has 2 outputs for that one input. So it's not a function, it is a relation only. Now the easiest way to go about this is to actually take a vertical line and just move yourself across the graph. I'm going to use a little tool here. I'm going to use my spotlight tool. I'm going to change this. And I'm just going to use the edge of the spotlight. All right, I'm using the edge of the spotlight to go across my graph. And if I start at the left of the graph and I start moving across, does my edge touch the graph more than once? Well, right there at the very edge, it touches it once technically, but the moment I move in, I'm touching it twice. I'm touching it up top and bottom. Right there, I'm touching it 4 times. Look at that, 4 times. 5 times I'm touching the graph there, and so on. And it doesn't matter how many times it touches it. If it touches it more than once at any point, it fails the test. That one is a relation only. Let's move on to the next one. I'm going to move my line across. Again, I'm using the right edge where my white dot there is to go across my graph. And I come here, and this one is a scatter plot. So I hit 1 point there, up, only 1 point touching. All right, I keep going on the scatter plot. Up, 1 point touching again. Okay, coming across, up, 1 point touching again right there. Notice I'm never touching 2 points at the same time. All right, with this right edge of my screen there. Up, 1 point, so still working, still working. Coming across, 1 point right there. All right, coming across, and 1 point right there. On this one, I never touched it more than once at a time, and therefore this one is a function and a relation. Let's do it again. Oop, wrong tool. All right, so coming across this last one over here. Again, I'm using the right edge All right, I'm using this right edge right here, okay? And as I come across, now that right edge is touching my graph. It's touching it once, still once. Keep going. Does my right edge of this gray box touch the graph or the relation more than once at a time? No, going all the way across, it never did. So this one is both a function and a relation. It is both. Let's take a look at a few more graphs. What about these lines here? Well, again, I'm going to pull up my square there, start at the left, and start moving my way across, and I notice it never touches that line more than once. Therefore, that is a function. Come across to the next one, a line that's going downhill negative. There it is, up in the top there, moving down across it. And it never touches that line more than once. Therefore, both of these are functions and relations. They are both functions and relations. So the question is, are all lines functions? Well, think about that for a moment. Pause the video. Are all lines functions? Well, coming back now, I'll show you this one right here. Does that one pass my vertical line test? Well, being that it's a vertical line, will it pass my vertical line test? Right now, I'm not touching anything, nothing, but all of a sudden, boom, right there, I hit that vertical line. How many times am I touching it? Well, I'm touching it infinitely. All right, it is infinitely touching there, there, all the way down. I have an infinite number of times that it touches. That makes this a relation only. All right, in fact, all lines that can be written in slope-intercept form, y equals mx plus b, are functions and relations. All right? But vertical lines, which cannot be written in slope-intercept form, but rather just written as x equals a, all right, just starts with x equals, those are the only type that are relations only. So vertical lines are the only type of line that is not a function.